Good morning, guys. Good morning, good morning. All right, we're gonna wait a little bit just to get some more people on, and then we'll go ahead and start, okay?
Hi.
Hi. I'm gonna move to the sun just so that you guys can see me a little bit better. Move over here. That's a lot better, good. All right, guys, we're gonna hold on for just a few minutes, and then we're gonna go ahead and start. We got some cool stuff I think you guys are gonna like today, so. Hi, Georgia, thanks for logging on. Give it a couple minutes, and then we'll go ahead and start. Hope you guys are all doing well, enjoying summer. It's kind of hard right now, but it's all right. Just that there's always stuff you could do. So I'm gonna go ahead. Sorry, you probably can't see me. I'm gonna figure out the best position. Okay.
What are we going to learn about today?
All right, guys. So we're gonna go ahead and get started, okay? So for those of you guys that maybe it's your first time doing this, my name's Ava. I am leading this program. It's called Summer Science, and we're gonna be learning kind of about something new, a question that you guys have had that you submitted to me, and we're gonna kind of go into it and do an experiment to explain it. So first thing we're gonna do is we're gonna go into like a little presentation to understand the question, the answer, and then I have a really fun experiment for you guys today. You're gonna like it a lot, okay? So I'm gonna say bye-bye, and I'm gonna move to my slideshow. So we'll kind of talk through what the question was, all right? Oh, and guys, one thing really quick, I asked you guys if you could turn off the video, because for whatever reason, when I'm presenting, sometimes it like switches like cameras and stuff, so it can get kind of confusing. So if you're at the end, I'm gonna have put in some time for questions, then you guys can turn on video. But just for now, no video. Thank you guys so much, okay? So I'm gonna go ahead and share my screen. Yeah. Here we go. So hopefully you guys can now kind of see where I'm at. All right. Okay. So for our meeting today, I got a question, and it says, what are elements? And that's a really good question, because I'm sure you guys have heard the elements before. And I kind of rephrase it as to what are the chemical elements, okay? It's something that comes up in science. You're gonna be seeing it a lot too as you take more science classes. And it's good to have a little understanding about what the elements actually are, right? Okay, so we're gonna start with this definition of an atom, okay? Maybe you've heard of the word atom before, but aren't super clear on what it means. So the word atom, it comes from the Greek word for indivisible, okay? So basically an atom is the smallest unit of matter that you can have. Okay, now you're probably wondering, well, what's matter? Well, how is it the smallest unit? So matter is anything with mass and volume, okay? So when I say anything with mass and volume, you can think water, you could think sun, you could think computer, you can think the air, the gases in the air. You can think anything that's around you, everybody, everything is considered mass, okay? Pretty much everything in the universe is considered mass. So an atom is the smallest unit. So if we were to break down all that matter into its smallest form, we'd find a ton of little atoms, okay? So if you were to take like a plant or something, if you were to like zoom really far in, you'd see it's just made up of a bunch of atoms, okay? So that's what an atom is. It's just the smallest unit of anything. If we were to break down whatever, it's the smallest unit. Think about if you have a cookie and you crumble the cookie and you get all those little tiny crumbs, that's kind of a good representation of an atom. So a couple of forms of matter I put up here. We have solids, there's liquid matter, and there's gas matter. All of them are matter because they have mass and they take up volume. Okay, so now atoms, going back to that, so within the first few minutes of the creation of the universe, you kind of think of Big Bang Theory we were talking about last week, atoms began to form. So the center of the atom right here, this little ball, is called the nucleus of the atom. And what the nucleus is made up of is these little small particles called protons and neutrons. You guys don't really need to know the function of them, but just know in the nucleus of the atom, there's protons and neutrons. There's little like microscopic particles if we break it down even more. Now, outside of the atom, you guys see like these kind of, I don't know, oval shapes. So what those are, those contain electrons, okay? So electrons are just another kind of particle. We have protons, neutrons in the nucleus, and then we have electrons outside of the nucleus of the atom. This is all though the atom still. And the electrons, they orbit the nucleus, and a lot of times people think of them like a cloud, like it's like a cloud around the nucleus, a cloud kind of orbiting the nucleus of electrons. But if we were actually to go into that cloud, what we'd find is these rings, okay? So electrons are kind of organized into rings. They're called orbitals. And each orbital or ring holds electrons that kind of surround the nucleus. So there's a couple of different ways to model it. So here's one way. You see these orbitals and you see the electrons, little rings. And then also too, you can draw it like this. We have the nucleus and then you have these rings and those represent the orbitals with electrons. You can see the little black electrons on there. Okay, so again, I know that's information overload, but just get in the back of your head, atom is the smallest unit of matter that we can have, okay? This is gonna come up a little later, but you don't need to know the specifics necessarily, the protons and neutrons and stuff. Okay. So now let's dive into, okay, how does atom apply to a chemical element? So chemical elements are matter that is made up of only one type of atom. Okay, so let's think about that, right? Each element only has one type of atom. It doesn't have atom A, atom B, atom C, atom D. It's just atom A or just atom B. So it's one type of atom. So matter that is made up of only one type of atom, that's when we get elements. They're really pure. So each element is different because they are made up of different types of atoms. So if you've seen the periodic table before, you see all these different elements. Well, they're all different because they all are made up of different atoms, okay? Remember, each element has one type of atom, but they all have different atoms from each other. That's what makes them different elements. So in total, there are 118 different elements, which means that there's 118 different types of atoms. You can see them all kind of organized here. Some of them by the metal, some of them by the inventor, or not the inventor, whoever discovered the elements. But basically, 118 different types of atoms have been discovered, which is kind of crazy when you think about it. Like it seems like a lot, but for all of Earth, to only be made up of only 118 atoms is kind of weird to think about. So those atoms are everywhere. The majority of the elements in the periodic table are metals, okay? So they're really good at conducting electricity, okay? If you know anything about electricity, you know electricity loves metal. So a lot of the metal elements are great at conducting electricity. An example would be lead. So you see lead right here. Okay, kind of you could think pencil lead, but this is a little bit more concentrated. And also the rest of the elements, right? And there's some, you see like these guys over here, the rest of the elements are non-metals, okay? So they are not metal. They aren't good conductors of electricity. And a lot of those non-metals are actually gases, right? And the gases can't conduct electricity. So one example of a non-metal is bromine, okay? So you see kind of the gas here, it's funneling out of that, funneling out of the container, just to show you guys that non-metals a lot of the times are gases, okay? So putting this all together, if you want to take a step back, remember, elements are just made up of one type of atom. Each element has its own type of atom, so its own little particles inside. I think about the cookie, like each, maybe one element's like a sugar cookie and one element's like a chocolate chip cookie. and it's made up of its own crumbs. It doesn't, a chocolate chip cookie isn't going to have any sugar cookie crumbs. It's going to be just chocolate chip cookie crumbs. So it's very pure in the atoms that it has. Okay, so now we know a little bit about elements, and you might be thinking, okay, what is the periodic table of elements? I'm sure you guys have seen this. It's on TV or in a book or something like that. You probably don't really understand how it works. So the periodic table of elements, it looks really confusing, but all it really is just an arrangement of all the chemical elements in a way that's easy to understand. Okay, so people can read it, see it, and understand it. So when we're looking at the periodic table, how we kind of read it is the rows. So rows are left to right. Okay, rows are like hot dog style. So row 1, row 2, row 3 here, row 4 here, row 5, row 6, row 7, row 8. You see it going across from left to right. So our rows are called periods. Isn't that funny? It's a periodic table. We do have periods in the periodic table. And each row represents the number of orbitals around each atom of the element. So wait, let's backtrack that. Remember what orbitals are. Orbitals are those rings that hold electrons, okay? So the rows represent, this is row 1, these elements, their atoms, they're kind of cookie crumbs, their atoms have one orbital. They have one ring to hold all their electrons. Now, if you go down here to like francium, right? Francium is row number 6. Well, in row number 6, all of these elements, guys, in row number 6, they have 6 orbitals around their atoms. So 6 little rings to hold the electrons. So as we move down, you're just adding more rings, more orbitals for those electrons to hang out on. So it's not like it's just a way to organize it and to make it kind of easy to see as they did it by orbitals. So remember, if we were to take the element and break it down, we get those atoms, and then we'd find all these orbitals. So we'd find for these elements, 6 orbitals. So adding orbitals. Now, the columns, so if we were to look at a hamburger style, we have all these columns. So 1, 2, 3, 4, 5, 6, 7, 8. We're going vertically. So this column, this column, this column, this column, this column. The columns are called groups, all right? And groups are elements that have the same number of electrons on their outer orbital, okay? So remember, electrons are on orbitals, they're on those rings. Now, even if hydrogen doesn't have as many rings as beryllium, okay, these are just 2 elements, even if they don't have as many rings, right? The idea is that regardless of how many rings it has, the outer ring has the same number of electrons. So this whole row, right, if we're taking, I'm gonna look at beryllium and calcium. So beryllium, even though beryllium only has 2 rings, it has the same number of electrons on its last ring as calcium does, even though calcium has more rings. It's that last ring that we're really looking at. So all that matters here is that last orbital, that last ring. And for columns, we're grouping together elements that have the same number of electrons on that last outer ring, okay? So just kind of, so this, in this column, this row, or I'm sorry, not row, this column, excuse me, this column, this group, they all have 1 electron on their outer orbital, on their outer ring. These guys, they have 2 electrons on their outer orbital or their outer ring of their atoms, okay? Remember, atoms, kind of like the cookie crumbs. So it can be kind of confusing, and there's a lot to take in here. So I'm not expecting you guys to know perfectly all about this stuff, but I just want to kind of give you a general idea and show you kind of what the organization is. It's all about the orbitals. It's all about the electrons and the orbitals. So now, if we were to actually zoom into one of those squares, so I actually zoomed into carbon here, what do all the numbers mean? Like, what's going on here, okay? So to read the square, each square represents an element. So we have all the 100, if you counted this, you find there'll be 118 elements on here. Each square represents an element. So when you're reading a square, so you have this symbol, okay? And the atomic symbol is just a shorthand way to tell us what the element is. So H would represent hydrogen, a C represents carbon, an O represents oxygen. I'm sure you guys have heard of oxygen before, and all those kind of, some of those terms have come up. Those are all elements, so they kind of have a symbol just to make it easier to see on the periodic table, okay? Just a shorthand. Maybe if you have a long name and you abbreviate it, you can think of the same thing. Okay, so now at the top, the number on top, this is the atomic number. And as we snake through the periodic table, ooh, snaking through here, we see that it's increasing, right? It goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, yada, yada, yada. It keeps going on. And what the atomic number represents is the number of protons. Remember, the protons were those things in the nucleus. We had protons and neutrons. It just tells us how many protons an atom of that element is going to have in the nucleus, okay? So it's just telling us protons. Right here, we get the atomic name. So we're actually getting the name of it, the full name, which is carbon. And then down here, this is the atomic mass. And this is representing the weight of one atom of the element, okay? So 12.01 would be the weight. If we were to take an element, if we were to take a block of carbon, we were to break it down into little atoms, and we were to weigh an atom, the average mass would be 12.01, okay? So just kind of thinking about that, it seems like there's a lot going on, but for the most part, this is, this is kind of the general overview of how it's organized, the periodic table. So hopefully now it makes sense. The guy that created the periodic table, now you understand like why he organized it in such a way. And it looks like really nice too. It's very appealing to the eye when you look at it. So it's a nice tool. Okay, so now we're going to what are the alkali metals? Okay, so alkali metals are group 1 of the periodic table. Remember, groups are going to be our columns. So this is group 1. These are our alkali metals. And alkali metals, basically, they contain the elements lithium, sodium, potassium, rubidium, calcium, and francium, okay? They don't contain hydrogen. Hydrogen's up here. You're probably like, why is he not in that group? Hydrogen's not a metal. So even though he's up there, he doesn't really get called into the alkali metal group 1 group, okay? So anyway, but alkali metals are group 1. Alkali metals, they're shiny and they're soft, and they're super duper reactive with water. So when they hit water, they'll burst into flames or explode, okay? So that's pretty much the alkali metals. Shiny, soft, but when they get in contact with water, it's really dangerous. So we have a couple here. I have lithium and potassium. Okay, here's another group. So what are the alkaline earth metals? So this is just, we're kind of going through the periodic table and understanding a little bit more about the elements that each group has. So alkaline earth metals are group 2. So they're our second column of elements. And those include calcium, magnesium, strontium, barium, beryllium, and radium. Usually these guys aren't found alone in nature because they're really reactive. So they will react really quickly. So they're not really found alone because it can be kind of dangerous. But they aren't as reactive. They won't explode as quickly as the alkali metals you just talked about, but they are pretty reactive. The first two groups, group 1 and group 2, they're pretty reactive. So the elements we got here, we have calcium, which you guys might have heard of calcium before, but this is actually calcium in its pure form without any kind of additives to make it, to change it. And then here we also have barium too. That's another element. Okay, what are the halogens? So the halogens are group 17 of the periodic table. So group 17, we're jumping, we're all the way over here. Group 17 is the halogens. That includes fluorine, chlorine, bromine, iodine, and acetine. And the halogens are really reactive, okay? But they do work well with those alkali metals, because remember, alkali metals are pretty reactive too. They like to react and make chemical reactions. They do work well to make different kinds of salt, okay? So you can think maybe, table salt, the salt that you have on your table, that's basically sodium, which is Na, and chloride. And remember, chloride is a halogen. Chlorine is a halogen to make table salt. So they kind of react well together. So these guys, halogens are a lot of times used for salt. So one type of halogen is the fluorine, and then another type would be iodine, okay? And you probably have seen some of this before, but not like this. This is their purest form. This is the element without any additives. So just get a good glimpse of this. It's pretty interesting. Okay, what are the transition metals? This is another section of the periodic table. So transition metals are groups 3 through 12. That's a lot of elements it covers, this whole part, okay? So groups 3 through 12. And the the transition metals, they're usually pretty hard, but they're soft enough where you can bend them. So if you were to take a hammer and pound it, it would bend. They're good at conducting electricity, and there's tons and tons of elements here. But the most popular, kind of like our star elements that you probably know, is gold and platinum. You would find them here in this transition metal group, okay? What are the noble gases? So noble gases, this is the last group we're going to talk about. This is group 18 on the periodic table. And in group 18, in the noble gases, they are obviously gases. They're usually colorless and odorless. They don't smell, they don't have any color that you can see, and they don't really go through any chemical reactions. So the noble gases include helium, neon, argon, krypton, xenon, and radon. So here's helium, it's filling the balloons, and here's neon. So when you see like a neon sign, like that's lighting like an open sign, it's actually a gas that's inside of there. There's a little gas inside of here that makes it bright to our eyes. And that's actually a cooler element, I think. So we talked about a lot of the different groups on the periodic tables and kind of like what they mean and who's in them and what kind of gases or metals. There are some more groups that we didn't cover, but they get kind of complicated. These are the main groups that I want you guys to kind of have an understanding of. Now you might be wondering, what about hydrogen? Like, why wasn't hydrogen in group 1? And I kind of touched on this, but hydrogen doesn't fit into the alkali metal group because it's not a metal, right? It's obvious hydrogen is a gas. So they can't really fit it into this metal group. So we just call it a non-metal, but it doesn't fit into the alkali metal group at all because it has none of the properties of the alkali metals. It's not a metal. So it just kind of hangs out on its own. It's a little special. So now you may have seen that there's 2 rows at the bottom of the periodic table, okay? And what do those represent? So those 2 rows, they represent the lanthanides and the actinides, and it's just more elements. And these were more recently discovered. And the only reason that they're separated is just because organization makes it way easier to read when you have it separated rather than like trying to shove these into the periodic table. It would kind of make things wonky. So they just kind of put them at the bottom to make it easier to see. But these are just some more elements here, okay? So another thing you might be wondering is, hey, are there any new elements that are in the process of being discovered that we're kind of working on discovering right now? And the newest elements that have been discovered and added to the periodic table would be element 113, and that is nihonium, element 115, moscovium, element 117, tennessine, and element 118, which is oganesson. Okay, so these are just some of the newest elements that have been added. When I say new, I mean like a couple of years, like 2016 they were added. So just kind of, we're discovering new things. Now, there is a little element 119. Remember I said there's 118 elements. There's a 119th element that's been named, but it hasn't actually been created yet. So scientists have an idea. It's called unenium. It's going to be element 119, but the problem is they can't actually put it in the periodic table because they haven't actually been able to create it yet. Okay, so scientists are working on actually chemically and you know, genetically working on some stuff to get this element to create it, but they haven't been able to do it yet. It's really tough. It's not an element that we just find naturally in nature. Like hydrogen, you're going to find it naturally in nature. Unenium, they're trying to create it and add something more to the periodic table and add a new type of atom. Remember, each element represents a different type of atom. So it's kind of cool that we're in the process of doing that. So, you know, I always like giving you guys a question to discuss because I think it's important as young scientists that you guys get talking with people and you can share your ideas. So hopefully what you kind of learned today about the periodic table, I want you to think about this. Do you think that the periodic table is properly organized? Or if you had the opportunity, if I gave you the periodic table and said, change it, would you change the arrangement of the elements and how would you do it? Okay, maybe you think that there's a better way. Maybe you think grouping it all metals and all non-metals or doing something different would be a better idea. So kind of think about maybe is there a different way we can organize the periodic table? Because it's been organized like this for a long time, but maybe there's a different way, okay? So that covers our little lecture portion. And now we're gonna get into something a little bit more exciting, our experiment. So what we're gonna be working on today is elephant toothpaste. Okay, maybe you've heard of this before, but it is really fun. And I'm gonna show you, it's a nice little chemical reaction that we can talk about some of the elements and what's happening, all right? So I'm gonna shift you guys over to now my camera so you guys can see the experiment happening, okay? Let's see stuff here. Okay, I think you guys can now see me, good. All right, so I'm gonna go ahead and move a little bit, just so I'm in the sun so you guys can see what's going on. Let's see. You guys still see my hand, yeah? Yeah, okay, good, good. All right. Guys, guys, and for this part, I asked you guys if you guys can turn off your camera, just because then sometimes it like pans to your camera and then the experiment, not everyone can see it. Thank you so much. Okay, so I'm gonna start by putting on my safety goggles, because remember, safety is so important. And today we're gonna be working with a chemical called hydrogen peroxide, okay? Hydrogen peroxide is, if it gets in your eyes, it can be really dangerous. So please don't do this experiment at home unless you have parent supervision. I'm wearing goggles, I'm being really safe, so please don't use hydrogen peroxide just throwing it around. It's really dangerous. Okay, so today what we'll be working on is I have a couple chemicals here. So first thing I have is a bottle. This is my bottle, okay? In my bottle, I have hydrogen peroxide, okay? Maybe you've heard of hydrogen peroxide before. There is a chemical formula, and we're gonna talk about it a little bit at the end, but this is hydrogen peroxide, okay? Bottle of hydrogen peroxide, put in half a cup, okay? So nothing else, it looks like water, it's actually hydrogen peroxide. So here we go. So I have this to start, okay? I'm gonna open it up just because we're gonna need it for later. So this is my hydrogen peroxide. Next thing that I'm gonna do is I'm gonna add a squirt of dish soap, okay? And we're gonna talk about why I'm adding this, but this is just regular Dawn, good old Dawn dish soap. So I'm gonna add a squirt of this, nice big squirt. Okay, there we go. Got a bug in my eye, sorry. Okay, so there we go. Now we have a nice big...
I can't see your bottle.
You can't see the bottle. Thank you for telling me that. Can you see it?
Please do not try to get it on the camera.
Can you guys see the bottle now?
No, it's not in camera.
No?
Yeah, now.
Yeah, okay, good. So I put in, thank you for telling me that. So I put in a squirt of dish soap. The next thing I'm gonna do is I'm gonna add in some food coloring, okay? Just so we can actually see, when we make the toothpaste, we can actually see it come alive. So I'm gonna add some food coloring in, and we're gonna do stripes today. So
Wow. If you move your camera down, then you can see it.
Yeah, you know what, you're right. Can you see it now?
We can't really see the bottom of it.
Yeah,
Yes, that's better.
That's better. Okay, thank you so much for telling me, guys, because I can't like see it on my end, but I appreciate it when you guys tell me that. So now I'm gonna add some food coloring, okay? I'm gonna add a drop of red. This is just along the side of the bottle, okay? And you wanna see what that does. Maybe add, and then I'm gonna add a drop of blue, okay? Because I like red and blue, I think it's kind of fun. Okay, a drop of blue. So here we go, I'm just gonna do it on the other side. Okay, so you have a drop of blue too. So I have a little bit of coloring. So now what I have is yeast, okay? And you guys have probably used yeast if you ever baked before. But yeast, here we go, it's just some yeast. I'm gonna activate it in water. So I have a tablespoon of yeast. I'm gonna pour it into this, I have a little, I like this cup, it's good for mixing stuff. So I'm gonna pour my yeast in here. And then I'm gonna add 2 tablespoons of warm water. And I have some warm water in my canteen here. So I'm gonna add in 3 tablespoons of warm water. We're just gonna kind of let it sit for about 30 seconds, okay? So, pour this in here. 1, 2, 3. Okay. I'm gonna let this just kind of sit. I'm gonna stir it around a little bit, and it's gonna look like soft ice cream, I guess would be the best way to describe this, but we're just gonna kind of let it mix around.
I can't see inside the yeast and water cup.
Okay. I'll lift it up for you guys so you guys can see it, but
That'll be fine.
see, I'm not kind of let the yeast go in there. See, yeast is so if you guys want to see the yeast, you can kind of see it just kind of like, just kind of hanging out, just kind of waiting and getting, it's just kind of turning into like a soft ice cream consistency would be the best way to describe it. So I'm gonna give it a little stir. I'm gonna let it sit a little bit, and then we're gonna get started on actually doing. So I want to explain something to you guys. What's going to happen? I don't want to give away the experiment, but basically hydrogen peroxide. The chemical formula for hydrogen peroxide is H2O2. Okay, 2 hydrogen atoms and 2 oxygen atoms. Remember those elements we're talking about? Well, for hydrogen peroxide, you end up combining them. You combine 2 hydrogen, 2 oxygen, put them together. So when we're doing this experiment, I have 2 hydrogen, 2 oxygen. I'm putting them in this bottle. And then I have yeast, okay? And what yeast likes to do, yeast likes to break those things apart, Okay, so yeast is going to break apart the hydrogen and the oxygen. It's going to make H2O, 2 hydrogens and an oxygen, water, and then it's also going to release oxygen gas. Okay, so that's what the yeast is going to do. The yeast is going to kind of break apart the hydrogen peroxide. Once you break apart the hydrogen peroxide, guess what happens? We end up releasing oxygen. Let's put dish soap in here. It's going to try to trap those bubbles, and we're going to see what happens when it traps the oxygen bubbles. All right, so let me check on my yeast, and I think it will be good to go. All right, guys, I think it's ready. Okay. So I'm trying to make sure I get all out of there. Okay. I'm putting it in this container because you'll see what happens, but there's a reason. So I think my yeast is ready. Ready, guys? Can you guys see the bottle?
Yes.
All right, I'm gonna pour my.
3, 2, 1, go.
You guys see what's happening?
Yes.
It looks like toothpaste. Can you guys see it?
I
Yeah.
do.
Isn't that cool?
Yeah. Except I don't see the red.
You don't see the red's on my side. I'll kind of twist the bottle a little bit.
I only see blue.
You only see the blue. Maybe you guys can see it.
Yeah.
Yeah, you guys see it now?
Look now. No.
No. See it exploding?
Yeah,
You
I only
do.
see the blue in the
Isn't that
dark.
cool?
That's okay.
I'm gonna let it kind of sit and explode. But basically what happened, guys, if we're looking at I'll show you guys what the toothpaste looks like on the bottom. If we're looking at the elements, guys, what's happening is we're taking hydrogen peroxide, H2O2, and the yeast helps to break it up. Yeast works like breaking it up. It's breaking it up into water, H2O, and oxygen. Oh, okay, so that's how we get the H2O2. And then the oxygen ends up getting released and it gets trapped by the dish soap to make this foamy substance, okay? So that's what the dish soap does, is it helps to kind of trap in the oxygen gas and make it really foamy. All right, so I'm gonna let this keep going. This is super cool.
Stopped.
It did, well, it's let's see, it's going a little bit more. Yeah, it's so fun. Ah, I like the colors it did too. That's cool. So while this is still going, I want to ask, does anyone have any questions about anything we did today? Elements, anything like that? You can use your camera or your video or audio for this you can.
I saw 6 elements in group 17, but I only heard 5 of them.
17. Oh, okay. So in group 7, let me see. Hold on a second. I have a list of, let me check my periodic table here. Group 17. Yeah, so group 17, we had fluorine. Yeah, you're right. So you only heard 5. So the other element is just part of a different group, that last element that you're looking at. Even though generally I said group 17 is all going to be, the group 17 would be the halogens, there is an element at the bottom that's not going to be a halogen. It's going to be part of a different group. So periodic table in
The
general,
unknown properties group.
it'll be in a different group. It's a group, I didn't explain it to you guys, but there's another group. It's kind of complicated. I didn't want to get into it, but that element would be part of a separate group. It's not part of the halogens. So that's good of you that you saw that. I'm happy that you saw that. But generally, yes, it's just going to be a separate group.
Yeah, it's in the, I call it the unknown properties group.
Yeah, exactly. So it's kind of like the misfit, you know. So sometimes the periodic table has a couple of misfits. So let's see this little toothpaste. It's definitely slowed down. It's still going, but it has slowed down. You're right.
The last 6 elements are in the unknown properties group because their properties are just not known. Yeah, they're all synthetic.
Exactly, and
They
you cannot
cannot be found in nature.
Are there anyone else have any questions?
Yeah. I saw the I don't have any. Why isn't earth, water, fire, and air on the periodic table?
Yeah, no, that's a good question. So when I'm talking about, what I was talking about is the chemical elements, right? If you're talking about water, fire, and air. That's just like, we refer to those as like the general elements of life, you know? But when we're periodic table, we're talking about the chemical elements. And you're talking about water, right? You said water. Water is made up of the chemical elements. It's made up of hydrogen, 2 hydrogen, and 1 oxygen atom. Okay, that's what makes up H2O. That's why you see the 2 there, 2 hydrogen, 1 oxygen. So we do, I mean, it's made up of some of the elements, but it itself is not considered an element. All right. So I hope that that makes sense. Basically, when you're saying like earth, wind, fire, air, those aren't chemical elements. Those are just kind of like general elements that we talk about with life. But chemical elements, we're talking about periodic table. And all those elements
I get it.
about is considered, they're made up of chemical elements. All right.
Yes, I get it. And the
Yeah,
other
good.
3 groups are the poor metals, also called basic metals or post-transition metals.
Yes,
Metalloids,
exactly.
sometimes called semi-metals, and
Metalloids, yeah. I'm glad
and
a lot about
and the
periodic table. That's awesome.
non-metals, which has 7 elements. One of them is hydrogen. Is all the
Yes,
and the
exactly.
unknown properties group,
There are
which
lots
is
of
the last 6
tons of groups on the
elements.
periodic table.
The heaviest element is, you guessed it, 118. Its most stable isotope is 294.
I'm just gonna squeeze the rest of this toothpaste out because it's kind of fun. But I have time for one more question. Does anyone have one more question before we log off?
Can you show us the tray?
Sorry. Oh, you want? Yeah, you want to see the tray? Of course. Yeah. Let me show you. So bottle over. But this is what the tray looks like.
Oh, that's
Wow.
Pretty
like a
gooey.
waterfall.
Yeah. There's
That's
lots
like
of
a waterfall.
foamy stuff coming out. All right. So guys, that's all I have for you today. Thank you guys for coming on. I think everyone, it seems like you guys know a lot about the periodic table, which was awesome. I hope you guys learned something new or you like the experiment. And I'll see you next time. All right. Bye. Have a
Bye.
Bye.
Bye.